Hello and welcome to a new session. This time, DP is introducing metal and metals to you. महाभारत में हमने कर्ण, दानवीर कर्ण के बारे में सुना था, जाना था और दानवीर कर्ण ऐसे कैरेक्टर थे, उससे आप कुछ भी मांगिए, दिल खोलकर वो दान में दिया करते थे। ऐसे उदारवादी कैरेक्टर बहुत कम देखने को मिलते हैं। और ठीक उसी तरह से जब भी आपको मेटल को याद करना हो, तो मेटल भी इसी तरह से दे डोनेट और दे गिव, दे लव टू लूजेस इलेक्ट्रॉन्स। ये इंपॉर्टेंट बात है। Therefore, metals are electropositive because electrons are going away from metals, so hence they are electropositive in nature. सबसे इंपॉर्टेंट बात मेटल्स के बारे में हमने बता ही दिया। बिल्कुल स्टे फोकस्ड टुडे। सो मेटल्स के बारे में अभी हमने देखा, दे आर electropositive. Why they are electropositive? They have a tendency, they tend to lose electrons. What's the correlation between electropositivity and losing electrons? Obviously, we know electrons are negatively charged particles. Electrons are negatively charged particles. So, when a metal is losing electrons, so the number of negative charges in that particular atom are decreasing. So the atom is converting into, the metallic atom is converting into a positive ion. We say a positive ion because electrons are moving away. So metals are converting to cation, we say. So the atom is converting to how? Let's take a look. Metal, when it loses electron, it may be n number of electron. In that case, it gets a positive sign here on losing electrons, on losing electron. This is the general reaction. And this M plus is a cation. These are positively charged. So they love to change to cations, the metal atoms. These are the metal atoms. They love to change to cations. So therefore, as the cation carries a positively charge, so therefore they are electropositive. First thing, that's very important. So they love to donate, they love to lose electrons. That's one of the foremost and important characteristics of metal. Now, let's come to some of the other properties of metals which makes them very, very special. This is very important property. Of course, the most important is electropositive as they tend to lose electron. Metals are ductile. D-U-C-T-I-L-E. Metals are ductile. Now, what is that ductility property? Now, ductility property is the property which allows a metal to be drawn into a long, thin wire. Especially, we can make wires. We can stretch it. That stretching capability is there with the metallic substances, especially iron, copper, aluminium, silver, gold, they can be stretched. So, ductility property. They are highly ductile. They are malleable. Metals are malleable. Now, malleable, when I say, this term has been taken from the property malleability. What is malleability? Malleability is the property of metal which allows them to be beaten into thin sheets. If you go to a goldsmith, you see small amount of gold, small amount of gold, they can convert it to a beautiful piece of jewelry, a broad one. You will think that it's the weight of that particular jewelry because the size is too large in dimension. But actually it's very thin sheet and beautiful design they can craft upon that piece of gold or silver. So therefore, that property is called as malleability. So malleability is the special property of metals which makes them very special. So they can be, metallic atoms can be beaten or metallic substance can be beaten into thin, very thin sheets. Like aluminium foil, you can see how thin it is, which are used to pack up foods. Next property, they are sonorous. They are sonorous. When you struck a string of a guitar, it produces a beautiful ringing sound. और गांव के स्कूल में जब पियोन घंटी बजाता करता था छुट्टी के टाइम पे, वो साउंड अब तक मेरे कानों में गूंजता रहता है. And you know, it's produced a beautiful ringing sound which can be heard from a distance too. Distinct, clear ringing sound is produced. That property is called as sonorous property. Lustrous property. Metals are highly lustrous, shiny property. Highly shiny property. Gold, silver, aluminium, iron even, when they are in the new state. So, new object. Then there is huge shine. Although gold and silver retain their shines over a long period of time as they are chemically less reactive, but others, they gradually, because of reaction with the atmosphere of various acids, of water and lot of other factors there, they keep on losing their shine. But it's an inherent property of metals that all the metals are shiny. Next important property is they have high melting point and boiling point. They have high melting point and boiling point. As in metals, you know, the particles are bonded very closely. They are tightly packed by strong forces of attraction. So we need more amount of heat energy to overcome, and hence their melting point and boiling points are pretty high. Most of the metals are solid except one. Can you name it? Can you name it? Yes. One such metal appears as a shiny substance, shiny liquid substance in the thermometer. Absolutely, you guessed it right. That's mercury. Solid except, so exception is mercury, and you know the symbol of mercury is Hg. They are very hard except, there are always exception. So in metals also they are generally hard except sodium and potassium. Here also except sodium, potassium and potassium. They have a pretty low MP and BP compared to other metals. Hard, they're very hard. Iron, aluminium. Aluminium is pretty hard. How? Because you know aluminium has a multiple utility. It's strong, hard, as well as very, very durable. And it do not, the oxide of aluminium initially when it is formed protects the inner layer of aluminium surface to be exposed to oxygen or air. So it prevents further corrosion of aluminium. So that's the importance of aluminium, and aluminium being lighter is used to make the bodies of the aeroplanes. So it's very important. So but sodium and potassium, they are pretty soft metal. They are very soft, very reactive, and they are so soft that you can take a kitchen knife और आराम से आप काट सकते हैं. They can be cut easily with the help of knife. So soft. They have high tensile strength. High tensile strength. They have high tensile strength. Now tensile strength means they can endure, they can, you know, basically they are not deformed when a lot of stress is put upon them. A lot of forces are put upon them, they do not get deformed, the shape do not changes. Hence they can bear a lot of stress on them. That's why they have high tensile strength, except obviously sodium, potassium and pure gold. Pure gold is not that, do not have that tensile strength. And especially the exceptions once again is sodium, so except sodium and potassium. The exception you should remember. These are some of the physical properties of metals. Now, So let's recap. What are the important properties? Metals are electropositive in nature. They have a tendency to lose electrons and form cations. Cations are positively charged ions. Ions are of two types, positive ion and negative ion. So metals forms positive ion. They form cation, sodium cation Na2, Na plus, magnesium ion Mg2 plus, calcium also forms cation, calcium ion Ca2 plus, aluminium forms 3 plus. Now generally metals have a characteristics of metals are they have 1, 2, 3 electrons in their valence shell. So that's the main cause of their reactivity. Some of the metals of course are very less reactive like copper, silver, gold, especially gold which lies at the bottom of the reactivity series. I will take a whole session on reactivity series. This is very important to know. But today we will focus on the physical properties of metals. So far we have discussed about the metals. Now let's focus our camera on non-metals. You stay focused. Let me rub the portion here. Let's now start for non-metals. Now, as we have seen that metals are electropositive nature, and non-metals are they have a, let me use a black marker. Non-metals are electronegative. That's very simple. They have a tendency to accept electrons. They accept electrons. For example, chlorine accepts 1 electron and gets converted to chloride ion. This is an anion. Chloride anion. Now, non-metals gain electron to complete their octet to become stable to achieve nearest inert gas electronic configuration. In short, you should remember they are electronegative in nature as they have a tendency to gain electrons. This is the first important property. They are non-ductile. They cannot be drawn into thin wire. They are non-malleable. They cannot be beaten into thin sheets. They are non-sonorous. They do not produce a ringing sound. Rather, they produces very peculiar sounds. Non-ringing sound they produces. So non-sonorous. They are dull except diamond, which is an allotrope of carbon. Next, they exist as solid, liquid and gaseous state and gaseous form. They exist as solid, liquid and gas. Now some solid, for example, sulfur, phosphorus, etc. Liquid, we know bromine, and gaseous form we have nitrogen gas, oxygen gas, etc. This nitrogen gas, which is quite inert in nature, is used for food packaging. Yes, you heard it correct. The chips packet and some foods which needs to be preserved over a long period of time, they are packed with nitrogen gas. Being inert, it makes a shield out around the food and it helps to protect the food from spoiling or reacting with the oxygen present. So it prevents the oxidation of the food and prevents rancidity. Very important role played by nitrogen. Oxygen is also gases. So it exists as solid, liquid and gas. And they are not hard. They are not as hard as obviously except diamond, which is an allotrope of except diamond. I need the space here. Now except diamond. And diamond is the hardest natural substance we know. So they are not hard and they have low MP and BP, low melting point and boiling point, except obviously diamond. Diamond has pretty high melting point and boiling point. And non-conductor of, yeah, one point I missed it, for the metals also. Metals are very good conductors of heat and electricity. You can include silver. Silver is the best conductor of electricity and heat. Here they are non-conductors of heat and electricity. H for heat, E for electricity. They are non-conductors of heat and electricity. Not hard, low tensile strength. They have low tensile strength. Let's recap fast all the properties of nonmetals. They are electronegative, they are non-ductile, non-malleable, non-sonorous, they are dull in appearance, they are not shiny except diamond, of course. They exist in all the forms, solid, liquid and gaseous state. They are not hard except diamond, which is the hardest natural substance. They have pretty low melting point and boiling point except diamond. They are non-conductors of heat and electricity except graphite. Low tensile strength. They cannot bear stress and they are fragile. They are fragile and brittle. These are the physical properties. In the next session, we'll take the chemical properties. We'll compare metals and non-metals for the chemical properties also. So till then, bye-bye. Any doubt, any clarification or any appreciation, please put it in the comment box. I will be taking it seriously and work upon your feedback. Till then, for the next video, I will be coming up with amazing video once again for you. So till then, bye-bye, take care and have a wonderful time. Bye.